Today we are talking about implicit functions and their differentiation. But before we start with this, please note this is the seventh video in the series of differentiation. If you have not seen other parts, please do watch them. The links are available in the description box below. Okay, so first let's understand what are implicit functions. Till now, we were dealing with functions like y equal to x square plus 2x plus 7 or y is equal to e raised to the power x. These functions where it was possible to express y entirely in terms of x. These are called explicit functions. These are explicit functions because it was possible to write y clearly in terms of x. Now, let's consider some functions, for example, x square plus y square plus say 7axy is equal to 0. Now if I try to separate y here, it is x square plus, I can take y common, it is y plus 7ax is equal to 0. Still if I try to write y, it is y plus 7ax is equal to minus x squared. Or if I write it entirely in terms of y, it will be minus x square upon y plus 7ax. So you can see, though I have tried to separate y only on one side, but we still have this y over here. And there is no way to separate this y or to bring it to the left hand side. So since it is now not possible to separate y completely or write y entirely in terms of x, these type of functions are called implicit functions. So these are implicit functions. Now let's see, if we have implicit functions, how can we differentiate them? How to differentiate these type of functions, how to find out the dy by dx for them. So let's consider a simple function x square plus xy plus y square is equal to 100. This is the example of an implicit function because it is not possible to write it clearly in terms of x or separate y completely on one side. So in these cases what we do is we leave everything as it is and we just differentiate with respect to x, and then at the end we try to separate dy by dx. That's the only method that works here. So I'm leaving everything here and just starting differentiation. So I will be differentiating on the left side also. So I can say d by dx of the entire left hand side. So it is x square plus xy plus y square. This is the derivative of the left side. Similarly, I will find the derivative of the right side also, which is 100, and in fact it's a constant, d by dx of 100. So when I differentiate x square, it is 2x, the derivative of x square is 2x, plus the derivative of xy. Xy is a product here, x into y. So I will use the product rule. So it is first function derivative of the second. Since it was y, so its derivative with respect to x will be dy by dx plus the second function, which is y, into derivative of first, that is 1, plus now I'm differentiating y square. So just understand it separately. Suppose I have a function like y square and I'm differentiating it with respect to x. With respect to x. So it's very interesting. When we differentiate y square with respect to x, it becomes 2y times dy by dx times dy by dx, because I am differentiating with respect to x. So x has to come here since the derivative of y square is 2y. But y will still be there because I am differentiating with respect to x. So it is dy by dx will still be left, is equal to the derivative of 100 is just 0. Now all I can do is I can collect the terms of dy by dx on one side. So let me take dy by dx common. So I am left with x plus 2y on one side, and rest everything will go to the other side. It is minus 2x minus y. So if I just separate dy by dx, my answer would be minus, let us take minus common over here. it is 2x plus y divided by x plus 2y, or 2y plus x, whatever you want to write. So this is the derivative of this implicit function. So very simple rule. Treat the entire function as it is. Don't try to separate y or x in any way, because that will not be possible. And now differentiate both sides with respect to x, and at the end try to collect dy by dx only at one place, the way we have done it, right? And the thing to understand here is it is y square. So whenever we differentiate y square, the answer would be 2y, but since we are differentiating with respect to x, so it will always be 2y times dy by dx. This is what you need to understand. So in a way, whenever we are differentiating y, dy by dx will definitely be there. So this is a point which you must note and understand. Now, let's take one more example. Suppose we have a function like this, sine square y, a very simple but interesting example. Sine square y plus cos xy. So it is cos xy is equal to, let's say, a constant. Can be anything, it can be a number also, but let's say k. Now, one thing which we need to understand here, sine square y, whenever we have to differentiate the sine square y, just understand that it can be written like this also. Sine square y can also be written as sine y whole square. Very, very important to understand. Sine square y can also be written as sine y whole square. Now, when you will be differentiating sine y whole square, for differentiation, we use a special method which is called chain rule here. I'm sure you are clear about it. If you need any revision, please go back and see my video on chain rule. So that will be clear. So sine square y, I'm differentiating. Okay, let's first write it this way so that you understand it better. So it is sine y whole square plus, I'm writing it as cos xy in a bracket. Please understand this is in a bracket, and then the constant is just k here. Now I'm differentiating both sides the way we did in the last case also. We differentiate everything as it is, and at the end we will collect dy by dx. So I'm not writing d by dx on both the sides, but straightway differentiating from both the sides. So it looks like x square at the moment. So I will solve it as 2 sine y, because the derivative of x square will be similar to 2x. So I'm writing 2 sine y. Now I have solved this power 2. So I'm only left with sine y. And I know the derivative of sine y would be cos y. But since I am differentiating with respect to x, so a dy by dx will definitely come over here. Plus, now I have to differentiate cos xy. So just assume it like cos theta, and we know the derivative of cos theta is minus sine theta. So you write minus sine xy as it is, minus sine xy. So I have solved cos over here, but I am still left with xy. So if I apply the chain rule for it, then it will be a product rule here. So I'm applying product rule to this xy. So it is first function derivative of the second plus the second function into derivative of the first is equal to differentiation of the right hand side being a constant would just be 0. Now let's collect the terms. We can notice dy by dx is here also with this term, and dy by dx is here also with this term, and the other term can go to the right hand side. So if I take dy by dx common, so let us take dy by dx common. I'm taking dy by dx common on the left hand side, so obviously I'm left with 2 sine y cos y on the left hand side here. After that, I am also left with minus x times sine xy, dy by dx can go common out, is equal to, when this much is getting multiplied, this portion, it is multiplied and then it can be taken to the right hand side. Since it is negative over here, when it goes to the right hand side, it becomes sine xy times y. So I'm writing y in front. Now let's say only dy by dx would be y times sine xy divided by, the whole thing can be divided by, this is 2 sine y cos y, I can write it as sine 2y, just using an identity, minus it is x times sine xy. So we can have this as an answer. So simple question. The only thing is we treated everything as it is, we differentiated both the sides, and at the end we collected the terms together to have the final answer. Alright, let's take one more question so that the entire concept will be very clear. I have a question like y plus sine y is equal to cos x. So I have to find out dy by dx, which means I have to differentiate it with respect to x. So to find the differentiation, I will treat it as it is and will differentiate every term. So it is dy by dx plus it is cos y, because the derivative of sine y is cos y, times dy by dx is equal to minus sine x. We are differentiating with respect to x, and the derivative of cos x is minus sine x. Now all we need to do is collect dy by dx from here, and you are left with 1 plus cos y is equal to minus sine x. And if I just find the derivative of derivative of the entire function and try to find out dy by dx, the answer would be minus sine x, and the whole thing is divided by 1 plus cos y. So this is how we differentiate implicit functions. Yeah, you can also see here some implicit functions and their graphs. That's all for now. The next video will be on differentiation of inverse trigonometric functions. If you could understand what I was trying to explain, please like and subscribe my channel, and don't forget to press the bell icon to get the notification of my latest videos. Thank you.